Acha, simulated annealing, the next algorithm. The next algorithm which we will discuss over here, that is called simulated annealing. As the name you can see yourself, simulated annealing. Annealing itself uh, is a process which is being adapted from the physics, a physical concept. It is derived from one of the branches of physics that is called metallurgy. And annealing is actually a physical process in which the metals are being transformed into various alloys. And actually what they do is they put those metals in blast furnaces. And as you know, the blast furnaces, they have a very controlled temperatures. There they can go even thousand of degrees centigrades or more than thousand of degrees centigrades to melt down those metals, or in other words, we can say to decompose those metals. And after doing that, what they do is actually they start uh, cooling down the temperature. It means from the highest temperature, what they do is they gradually lower down the temperatures, and at a particular point in time or at a particular temperature, they achieve a state of the metal which is required actually. And that state of the matter has then various other properties which was not there in the actual metals. So that is one of a very interesting physical process. And those alloys are being used in making of various things, for example in aircraft industry, space shuttles and other things like that. So that is actually a physical process. Now, the question comes in our mind is that how we relate annealing in computer science, or what is the relationship of algorithm with this concept, physical concept. So that is try to understand this thing, because what I have discussed with you is the process. So in the simulated annealing algorithm, the concept of the process is actually adapted. And if you understand the concept of the process, is what is the concept? That initially you go to the highest temperature, number one. Why you go the highest temperature? To totally decompose the metal, or you can say you want to have a shape of the metal which is totally decomposed. And then what is the process? The process is to gradually and slowly lower down the temperatures, or in other words, we can say cool down the temperature. And at a particular point in time, at a particular temperature, we achieve that state which is desirable state of the metal. And that state is called an alloy, which is being used for various purposes. That is the basic theme of this. So some student might ask me that the same temperature which they want to achieve also came when they were heating that metal. So remember, when you are heating the metal, you will not achieve that particular state. Let's suppose at 700 degrees centigrade, you will not achieve it. How you will achieve it? Once you go for the highest temperature, let's suppose 1200 degrees centigrade, then lower down, then you achieve that state. So going upward toward the process, you will not achieve it. That is the concept. So lower down the temperature means cooling the temperature. So that is the basic concept. So actually in simulated annealing algorithm, that concept is being adapted. Obviously in computer science, we do not have blast furnaces, and we do not put our computers into it. Actually here, what we do is we adapt the concept. Because we have adapted the concept, that is why it is called annealing. And simulated, of course, it is simulated, not in the actual annealing, what we are doing is we simulate it in the form of an algorithm. So the basic idea is again the same. Um, that is escape the local maxima by allowing some bad moves. Here what we do is we do not go directly to that temperature. What we do is we achieve the worst situation. So the highest temperature means that achieving a worst situation. So in simulated annealing algorithm, you can say that we can achieve the worst situation, and what we try to do is that we try to improve it. We try to improve it. How we improve it? By gradually decrease their size and frequency, or in other words, by lower down the temperature if you compare it with the actual annealing. So that is the basic concept of this algorithm. Let's take an example to understand the concept. Let's suppose if I ask you to hold a tray, a big tray in your hand, and if I ask you to take two ping pong balls, and there are two places where those ping pong balls has to go, let's suppose, and if I ask you to shake it fast, what will happen? If you shake it fast, obviously those balls will go outside the tray because you not handle it. So if you gradually control your movement of the tray or jumping of the tray, then you will be able to put those balls into the required places. So that is basically the concept of annealing, because once you achieve the worst state, once you achieve the worst state, then it is easier uh, to improve it and get the possible scenario, or get the possible situation which is required. Now, by having this discussion, now this is the algorithm we have for simulated annealing. Just try to understand a very simplistic algorithm. What it says, let's see over here. Simulated annealing, what is required? The problem and the schedule. When I say a problem and a schedule, it means whatever the problem you are solving, whatever the situation you have, wherever you are applying the simulated annealing. Let's suppose you are applying it to 8 queen problem, so that is your problem. Then schedule means that number of states you have, how many states you have, and in that manner, what you do is uh, that you come out with a solution state. So we have the schedule, means we have the number of states and given problem. So what is the problem? A problem and schedule. But schedule is what? A mapping from time to temperature. So here, when we are making these algorithms to solve our problem, obviously, temperature has no concern over here, because we are taking the concept of annealing. So here, actually, the temperature is a mapping of from time. So from time to time, whatever the states we have, it gives the temperature. So if you go to the highest state, it means you are at the highest temperature, the worst state, and then gradually with the passage of time, you can manage it. So what are the variables which are here? Number one, the same thing which we have discussed earlier on, because it is an iterative improvement algorithm. So here always these two nodes are relevant. What are these two nodes? The two nodes are the current node and the next node, because we are talking about improvement algorithm or iterative improvement algorithm. So here the current node and the next node. So where and T is what? Is a temperature, is a variable which controls the problem downward step. So either you can have a loop of let's suppose you have the T value, let's suppose you have the T value 100, then you will lower down it, you will check it at 99, then you will check it at 98, then you will check it 97. Let's suppose you achieve your solution at 67. So that is the lowering the temperature. So actually that is the mapping you have with respect to your problem. So what you do is, first step, you need to have a current state. So here you have to have an initial state. So even in the hill climbing algorithm, when we apply that algorithm, we need to have the initial state. And there, how we achieve the initial state? In the hill climbing, we achieve the initial state by randomly picking any of the state. So let's suppose in 8 queen problem, we have thousands of states. So if randomly I pick one of them, let's suppose the value of H is 8, as we discussed earlier on. So what we try to do is that in the hill climbing, what we try to we try to improve it. Here, the initial node of the problem is whatever the problem is. What we have to do is we have to start from there. So what we do is that we make a schedule of T. And that schedule of T, I represent it on the top. It's a mapping from time to temperature. So the next state is what? Here we'll also select the randomly selected successor of current. So what we do is, again, we generate the successor and we pick any one of the successor from the current. And what we do is we calculate the delta. What is the delta? Delta is a change. Delta is a change. What is the change? Value of next minus the value of current. Okay, if the value of next minus value of current is greater than 0, then the current will become the next. Else, the same thing, not with the probability, that leave the probability, that is the probability of you can say that might not accept the value. So let's leave the probability over here. Just talk about the comparison here. So in that manner, we move on. So we always generate the next value. We calculate the delta. Delta is, in other words, you can say the change in temperature. That is the delta. So let's suppose we have 100 Celsius, not here in the algorithm. So we 100 Celsius, the next values obtained at 98. So what is the delta? Delta is 2. So always we consider the delta. तो जहाँ पे ये वैल्यू लेस देन 0 हो जाए या इक्वल टू 0 आ जाएगी, तो इसका मतलब है यहाँ पे हमने रुक जाना है सिमुलेटेड एनीलिंग एल्गोरिथम में. So that is the way it works. So it has, the concept is same, not the concept, you can say the actual, there were three things we were discussed, the iteration, the improvement, okay? And third thing is that there is no relevant path. So in simulated annealing also, the path is not relevant. That how you achieved the exact temperature or the temperature which is required. So you don't need to follow the path. You just need to achieve that particular state. So here also the path is not relevant. Here also there are iterations. So obviously in one iteration you cannot do it. What you do is you lower the temperature down and then you will find out that that state is required. And similarly in the third one is what is the improvement. So every state, the importance is the here in this algorithm is the improvement. So if there is no improvement, the state remains the same, or there is no difference, or whatever the state is required is being achieved, then there is no need to lower down the temperature. Then you have to stop. If you lower down further, then it means you missed out the solution. So that is the overall concept of simulated annealing algorithm. So we have discussed the hill climbing search algorithm, then we have discussed the simulated annealing algorithm, and now we will discuss the concept of genetic algorithm, the third algorithm. So that is the third one, that is called genetic algorithm. Now, when I talk about genetic algorithm, the genetic algorithm similarly comes in our mind at genetics. Oh, genetics exist among the living things, living species. We talk about genetics of humans, we talk about genetics of animals, we talk about genetics of plants. So we always consider genetics which is being applied for the living organisms. And genetic science or genetic engineering is a term which is actually came from the biological sciences. So one question you might ask me, that what is the resemblance over here? So again, so we are not actually doing genetics in computer science. What we are doing is that we adapt the concept of genetics or genetic science or genetic engineering. We apply that concept into our algorithms to find out the solution. That is the main thing. Now come towards briefly, what is genetics? If you people might have the idea that every individual has its own genome structure. So every individual has its own genome structure. And that genome structure or a gene normally represented as DNAs. You have heard about it, DNAs. So normally every individual, every species is being identified also as DNA. Recently, you heard about a PIA incident, and you know how they have identified the people because the bodies were burned down. So how they have identified the people? They have identified the people by conducting DNA test. So identify who he is. So they what they do is they compare it with their blood relatives. So they have some common things. So whenever we have DNA, so in a family we also have some common elements. If a DNA of, let's suppose, a DNA of son with a DNA of father, similarly the DNA of brothers, and they can be identified. Although they have separate DNAs, but they have some common properties which might exist. So it's a biological phenomena. The other thing about genetics is genetics believes that every species or an individual have certain characteristics which are being represented in the form of a DNA. Always remember that every individual has certain characteristics. What are those characteristics? जहन में सवाल आता है कि यार कौन से characteristics? So all kind of characteristics. For example, your physical characteristics are also part of your gene. What are physical characteristics? Physical characteristics are, let's suppose, the skin color, the color of your eyes, maybe your heights. What are the color of your hairs? These are what? These are all physical characteristics. So physical characteristics are also defined in DNA. And apart from physical characteristics, uh, there are other things as well, as science discovered that it is also described in the DNA. For example, the behavior of an individual. Some people have a different way of thinking and personalities, and all these things are also sometimes relevant to the the behavior. हम लोग कहते हैं कि यार ये बड़ा खामोश रहता है, ये इतना बोलता नहीं है. ये सारे भी कैरेक्टरिस्टिक्स जो बचपन में डेवलप होते हैं, इनमें अक्सर हम डीएनए में कैरी करते हैं. तीसरी चीज, ऑल डिजीजेस वी हैव. तो जब हम चीज कैरी करते हैं, इफ वी कैरी समथिंग, वी कैरी सम गुड थिंग्स, वी आल्सो कैरी सम बैड थिंग्स. So disease is also there are some diseases which according to the science we can carry it from our ancestors. That is quite possible. Let's suppose my parents are also diabetic, so maybe some of your parents maybe have that problem. So whenever you go to the doctors, first of all, they ask you, okay, you have you have diabetes. Let me know. Who is there any other person in your family having diabetes, or your father might have diabetes, or your mother? So why they are asking it? Because they think that the people who have this disease, their ancestors have more chance, the descendants have more chance that they have that disease. Similarly, you have heard about one very dangerous disease that is called thalassemia. So the same thing with the thalassemia. There is thalassemia minor patients as well. There are thalassemia major patients as well. So there also means they think that if one of the parent have this problem, then the child might have that problem. So that is another example of genetics. Now I hope that you understand the concept of the genetics in terms of biology. So the concept is being used over here, and in biological perspective, that every species or every descendant, or you can say, is basically an outcome of his or her ancestors. तो हर species अपने ancestor से फिर drive होता है ना. अगर मैं हूँ तो आई हैव जो मेरे कैरेक्टरिस्टिक्स होंगे, मैं कहाँ से ड्राइव, मतलब मेरे जो कैरेक्टरिस्टिक्स ड्राइव कहाँ से होंगे. माय कैरेक्टरिस्टिक्स विल बी ड्राइव मोस्टली फ्रॉम माय फादर एंड फ्रॉम माय मदर. I said mostly, not 100%, but mostly yes. The characteristics are being carried out from the father or mother or maybe grandfather, grandmother. So that is the way. And obviously, if my child is there, so a lot of characteristics of myself or even my father or mother has been transferred to my child as well. So that is the way it moves on. So how, what is the relevance of now genetic algorithm into our computer science or our problem? Now we'll try to have that concept. So we'll do with the simulation of this thing so that we can see. So here in this genetic algorithm, actually we have these 5 concepts. You have to try understand the 5 concepts. One is called fitness. Second is called selection. Then it is called pairs, then it is called crossover, and the last one is called mutation. These are the 5 steps which are important whenever you want to apply this algorithm to solve any problem. So here, for using genetic algorithm, one thing is very important, that you need to have population. So once you have the population, only then you can apply it, of course. सो पॉपुलेशन होगी तो फिर मैं उनसे नए ड्राइव करूंगा और मैं वो अचीव करूंगा जो मुझे चाहिए, या मैं बेस्ट अचीव करूंगा जो मुझे रिक्वायर्ड है. ठीक है. So for any given problem, we need to have the population. Let's suppose for the time being, we take the example of 8 queen problem. So in the 8 queen problem, what is the population? Population is the possible number of states. तो 8 queen problem में कितनी स्टेट हो सकती हैं? द बोर्ड हमारा कितना होता है? 8x8 का बोर्ड होता है और उसमें 8 क्वीन को प्लेस करना है. तो इसके कॉम्बिनेशन निकाल लो, कितने निकलेंगे? आप निकाल लो. 8x8 बोर्ड है, 64 स्क्वायर्स हो गए. तो 64C8 लेट्स सपोज कॉम्बिनेशन ड्राइव कर लो, तो कितने निकल आएंगे? अगर आप कैलकुलेट करें तो बहुत बड़ी फिगर निकल आएगी. तो दैट इज, जो ऑल पॉसिबल स्टेट्स हैं, दोज विल बी रिप्रेजेंटेड एज पॉपुलेशन. याद रखिएगा, all possible states of the given problem which you drive is considered as what? As population, number 1. So once you have the population, now let's suppose this column represents the population. So DNA, as you know, is represented in terms of certain digits and numbers. So here also this strip, you can say strip, this strip represents 1 chromosome or 1 possibility or one state of the population. This is another state of the population. This is another state of the population. This is another state of the population. And let's suppose there are many. Let's suppose 10 lakh states are there. So this is termed as population. What we will do next? So when I generate all the population, there is one thing which will happen. I may get some very good states. I may get some mediocre states. But I also get some states which are very worse. ये बिल्कुल ऐसे ही है कि मैं किसी फिजिकल काम के लिए शहर में से 1000 लोगों को मुंतखब करूं, पॉपुलेशन अपनी उठाऊं और फिर मैं उनको टेस्ट करूं. तो जरूरी तो नहीं है ना कि वो सारे 1000 जो जिनको मैं टेस्ट करूंगा वो मेरे कैरेक्टरिस्टिक्स पे पूरे आएंगे. तो कुछ बिल्कुल पूरे आएंगे, कुछ करीब करीब होंगे, कुछ लेस होंगे, कुछ बिल्कुल मेरे लिए जो है ना वो एक्सेप्टेबल नहीं होंगे. तो बिल्कुल ऐसे ही है, जब पॉपुलेशन हम लेते हैं, पॉपुलेशन में अच्छी स्टेट्स भी आएंगी, वो स्टेट भी आएंगी जो रिक्वायर्ड नहीं है. तो क्या करें फिर हम? तो हियर व्हाट वी डू इज वी अप्लाई द फिटनेस प्रिंसिपल. फिटनेस मींस दैट you apply function according to your own problem to select from the population. So what you do is you select from the population. So आपने क्या किया? आपने फिटनेस फंक्शन लगाया. आपने कहा अच्छा भाई वो सारी स्टेट्स ले लो जिसमें h की वैल्यू जो है ना वो लेट सपोज 5 से या 7 से ज्यादा ना हो. तो आपने वो सारी ले ली जो 7 से. तो आपने अपनी मर्जी का फिटनेस फंक्शन लगा दिया. जब हम फिटनेस फंक्शन लगा देते हैं तो ये जो रेड वैल्यूज आपको नजर आ रही हैं ये फिटनेस दिखा रही है, यानी इसकी फिटनेस 24 है, इसकी 23 है, इसकी 20 है, इसकी 11 है, सो ऑन सो फोर्थ. तो फिटनेस से हमने क्या फायदा होता है कि हम वो स्टेट्स की फिटनेस देख लेते हैं, कौन सी स्टेट्स की क्या वैल्यूज हैं. एंड देन व्हाट वी ट्राई टू डू इज दैट वी एम्प्लॉय द सिलेक्शन प्रोसेस. इन द सिलेक्शन व्हाट वी डू इज जो अच्छी वैल्यूज जिनकी फिटनेस की वैल्यूज हैं उनको हम ज्यादा भी इस्तेमाल कर सकते हैं. यानी लेट सपोज ये वैल्यूज अच्छी वैल्यू है 23 की, तो मैं इसका क्रॉस ओवर इसके साथ भी ले लूंगा और इसका क्रॉस ओवर मैं इसके साथ भी ले लूंगा. लेकिन लेट सपोज ये जो 20 है इसका क्रॉस ओवर सिर्फ मैं 1 के साथ लूंगा, 2 के साथ नहीं लूंगा. और लेट सपोज इसकी वैल्यू बहुत कम है, इसको मैं क्रॉसओवर में लूंगा ही नहीं, इसे मैं लूंगा ही नहीं. तो ये दैट इज द इंक्लूजन क्राइटेरिया. इन अदर वर्ड्स यू कैन से इट्स द इंक्लूजन क्राइटेरिया. So in this inclusion criteria, what you do it next is you form the pairs. Pair means that you will make the pairing so that you make the crossover. तो हम पेयरिंग बना लेंगे किसकी? पॉपुलेशन की. जब ये पॉपुलेशन की पेयरिंग कर ली, एक ग्रे में आ गया, एक व्हाइट में आ गया, यू कैन सी योरसेल्फ, एंड हियर वी कैन मेक द क्रॉसओवर्स. क्रॉसओवर में क्या हुआ? लेट्स सपोज इन दोनों का हमने क्रॉसओवर किया. व्हाट इज द नेक्स्ट स्टेट? लेट्स सी ओवर हियर. दैट 327 फ्रॉम हियर कम्स ओवर हियर and 48552 from here goes over here. This is the new state. And let's see here, 247 is here and 52411 is here. You see that we have generated two new states out of it by applying the principle which is called crossover. So what we did, we generate the new state. थोड़ी देर के लिए यूं सोचें कि भाई हमारे फादर हैं, तो हमारे फादर के अपने कैरेक्टरिस्टिक्स हैं, हमारी मदर के अपने कैरेक्टरिस्टिक्स हैं, और मेरे या आपके अपने कैरेक्टरिस्टिक्स हैं. लेकिन इसमें मेरे और अपने कोई कैरेक्टरिस्टिक्स नहीं आ रहे, या तो मेरे फादर के आ रहे हैं या मेरे मदर के आ रहे हैं. लेकिन ऐसा नहीं होता. वी हैव लॉट्स ऑफ कैरेक्टरिस्टिक्स ऑफ आवर एंसेस्टर्स, बट वी आल्सो हैव सम अदर कैरेक्टरिस्टिक्स व्हिच मे बी नॉट देयर. तो मेरे अपने इंडिविजुअलाइज कैरेक्टरिस्टिक्स भी होते हैं ना. So how we add the individualized characteristics? We add the individualized characteristics by this process that is called mutation. So once we have these crossovers, when we have these new strips, what we did here, let's see over here, we replace 5 with 1. It means that we have added a new characteristic into it, which was not the part of even from both the ancestors. Actually, it is the new characteristic. So in this way, we get a totally new strip, which is the product of two, but it goes through a mutation. So जितने ज़्यादा ये multiply होते चले जाते हैं, उतनी ज़्यादा इनकी mutations बनने लगती हैं. और we will continue this process until we achieve the states which are the best states. तो फिर हम कोशिश करते हैं इसी प्रोसेस को कंटिन्यू रखते हैं. कब तक? जब तक के म्यूटेशन के बाद वी हैव द बेस्ट पॉसिबल स्टेट्स अवेलेबल. इन दिस वे द जेनेटिक एल्गोरिथम वर्क्स. ठीक है जी. दिस यू कैन सी नाउ हियर विद द एग्जांपल. लेट्स टेक द 8 क्वीन प्रॉब्लम. दिस इज, लेट्स सपोज दिस रिप्रेजेंट one strip and this represent the second strip. Now the combination of these two, what happened? Now this first part come over here and this second part come over here. So we have come out with a new state. You can see this, you have observed in the previous algorithm as well. But let's suppose if I change this queen position from here to here, it means I did mutation. Mutation gives me a new variation. Mutation always give you new variations. Now, in these days, we have this COVID scenario, and you know that we are going through with this pandemic. So here you have also heard from people that there are new mutations. What does it mean? It means that coronavirus might come out with new variations. So we are dealing with 1 or 2 types of variation, but since a lot of people having this problem, so after these various crossovers, they might come out with new mutations. So here, whenever we perform the mutation, what we try to do, we try to achieve a state where we want to achieve the H value 0. So wherever the H value is 0, let's suppose we have achieved the solution, that is the desired state. So genetic algorithm is being used in computer science to solve various problems. Let's suppose you want to select a team of cricket team. So there are so many players who are playing in Pakistan. So let's suppose you select 250 players in your algorithm, and what you try to do is you try to form a team of 11 players, which is the best possible team out of these 250 players. So what will you do? You will have the characteristics of every cricketer. When I say characteristics, it is relevant to the given problem. What is the problem? You are selecting a team. and you are selecting a team of a cricket. So it means the characteristic of the player includes some of the demographic element, but mostly their performances in terms of runs scored, in terms of matches played, in terms of wickets taken, in terms of man of the matches, blah 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 blah. So all of these are what the characteristics of the individual. So you have all the data of all the players, and then you will come out with various combinations. So 250 players के 11 की टीम बनानी हो तो कितने पॉसिबल प्लेयर बन सकते हैं? बहुत सारे बन सकते हैं, लेकिन सारे नहीं लेंगे आप. क्यों? क्योंकि whenever you are forming a cricket team, there is a certain structure of the team. Obviously, there will be one wicket keeper, there will be 4 bowlers, there will be openers, there middle order batsmen, blah blah blah. So spinner. So you have to construct a team in that manner. ये तो नहीं हो सकता कि अब आप कहो कि सर मैं 11 बैट्समैन की टीम बना दूंगा, 11 बॉलर की टीम हम बना देंगे, तो नहीं, ये गलत हो जाएगा. So what we do with all these aspects, what we can generate the algorithm. I did this in one of my research paper, and that is being published and that is available on the internet, where we applied the genetic algorithm to form a team. So that is just for an example. Let's suppose you want to make teams of the students. Let's suppose I have 300-400 students, and I want to make the groups of the students so that I can maximize their performance. So I can also apply a genetic algorithm over there. So lots of in games we can apply the genetic algorithm as well. It requires lots of computation. So genetic algorithm requires lot of computation, and obviously that computation is why a lot of computation, because you see that we have to apply the fitness function, then we have to apply the crossovers, and this process continues on. तो ये तो लंबा प्रोसेस होता है ना, बार बार चलता रहता है और काफी देर तक, और नंबर ऑफ स्टेट्स भी बहुत ज्यादा है. So it takes a lot of time. That is basically, I'll end up over here. That is the concept of genetic algorithm.